Alright, good afternoon everyone. Welcome to today's Teacher Jason Sec 4 EMF lesson on a wonderful 2 p.m. Alright, so what are we doing today? In fact, before I go through this, just remember to be patient and understanding along the way, even though when you're typing, observe what you're typing as well, be gracious and respectful. And lastly, along the way, please ask good and relevant questions. So what are we doing today? In fact, for today's particular lesson, we are going to revise in the form of a mock paper as said last week. For those who have not attempted the mock paper, it's okay. The questions will still be gone through detailedly as well. So we will be going through what we have revised or studied in the previous reading class lessons, sets, probability of combined events, and lastly, the core of your statistical data analysis. So let's get to it and start with a few revision. In fact, this has been gone through for quite a while, but in some way, let's revise. The first one is what we call a universal set. Alright, so when you see this notation over here, just recall that this is actually to what we call a universal set. Following on downwards, what happens? Let's follow. Okay, this is saying that it is an element of something, right? And following up with a backslash, okay, it is just saying that it is not an element of something. Alright, that is something we can take note of, not an element of. Okay, then afterwards, following up, okay, just follow me through. Okay, this one without the equal sign is what we call a proper subset. Alright, with the equal sign, we say it's just a subset. Alright, because the sets can be equal. Just a quick recap over here. After that, with this notation over here, we can call this the empty set or the null set over here. There are two names for it, empty set or the null set over here. Okay, following up a few more notations, the U looks like the union, the N looks like the intersection, okay, or we call it intersect. Okay, next up, following up, if I call a set A and there is a apostrophe over here, indicated at the left side of the slide, I call that the complement of set A, complement of set A. And lastly, with the N over there, I say that this is the number of elements in set A. So all these notations over here, please do take note, alright? This is what we have gone through, I think, in your previous lesson, just that in summarized form. That's why I'm just roughly going through in a clear manner so that you don't have to go through it again at your side. Alright, so next up, what happens? Moving that up, alright, very, very quickly. So, first power question ready. Wow, that was fast. So this is actually the first mock paper, question 1A. So, before we go on, in the mock paper, what happens? You are asked to shape. But what these questions ask, you take note, we are asking for this notation over here, what we have went through all of it. A union B intersect. So if I were to read this in words from the weekend that we had just now, how do we actually do it? Alright, this one there's only 30 seconds, so make sure you read it. I'm actually trying to give you all some time to read the words, okay? But I'm just now going to launch the bubble launcher. Give me a moment. In 3, 2, 1, let's go. Alright, not very long, alright? Give me some time. What does it mean for A union B prime? A union B prime. So what do I mean when I say this, please? Alright, going good. Okay, last 5 seconds. 3, 2, 1. Alright, I have all of you attempted and all of you got it right. That's good. Alright, but let's see what it means first. So if I'm looking at A union, I'm looking at all the things that are contained inside. So A union B prime. So what does it mean? This means in this case, oh, I'm actually looking at set A. This is set A. Over here, set A. And this is or. And in this case, I want to highlight the other set, or in this case, B prime. So in this case, complement. So for that, let me just do some rewriting over here. Complement. Complement of set B. So I'm looking at set A or set B, which means I can contain both of them. Now that's where you realize if I'm talking about outside, outside is not, because this means this is A union B prime. I'm looking at outside set A and set B. Okay, A union B, and this is areas outside of the intersection is actually this notion over here. And so if I'm looking at the common areas means intersecting between the two. So A intersect B prime, and therefore the answer that leads to it's number one. So for those who have attempted, all of you got it right. That's good to take note. But now, okay, but for those who did not answer, I hope you understand how this is gone through. Alright, that's good to hear. But now let's look at the actual question instead. So I want to actually shade the set A. Okay, so let me just color code them. A, shade the set A with the union of B prime. So I'm looking for this. So what is A? So I hope for 4. Okay, let me go back. For 4 is going to be, oh, okay, sorry, I'm blocking. So let me just do some magic. Make myself disappear. Okay, Denise, can you see the writing for 4 now? Alright, so I do hope this is A intersect B prime. Okay, that's what it means by the area outside. Okay, I hope you take a screenshot and let me appear again. Okay, so now if I look at this particular mock paper again, A union B prime, what does it mean? So all I'm doing, what I'm doing is this one over here. A is none other than the area over here. Alright, so I'm just gonna shade. Give me a while. Let me remince my primary school memories of coloring. Okay. So this is A union B prime. So what B prime? So what I'm doing is B prime is the area outside of B, which is none other than this area over here. Okay, so if I'm actually looking at A union B prime, can you all tell me in this case, am I looking at the areas only formed by the red color highlighter, yellow color highlighter, or for both of them over here? Red, yellow, or both highlighted. Write down your answers for me. So I want to see what I'm looking at. So in this case, two notions. Alright, Denise has given me an answer. Let's give it to the rest. Am I looking for only the yellow, only the red, or both colors that have just green over here? In this case, there's some yellow over here. Some yellow. Alright, so I'll give you some time to think about it. Is it going to be only the red, or the yellow, or both? Alright, Fiona has given me an answer. Well, I'll bring it out to the floor, let you all think about it. Which ones are we looking at? Okay, so in fact, if you take a look about it on this particular slide, we're actually looking at both colors. What do I mean by both colors? Why both colors? Because I'm looking at A or B prime. So it's A or B prime. Okay, so it can be either in A or B prime or both. So therefore, I'm looking at both red and yellow colors, and in fact containing both. I hope this is clear for you, Fiona, for your answer, and for your Fiona, I didn't see your answer for that, but yeah, very good. That is the correct answer from there. And yes, I hope you guys understand why I mean for union. In this case, you consider red, yellow, or both. Right? Okay. Now, next up again for today, bubble questions are going to be very fast flowing. Bubble question number 2. So before I go on to this bubble question, let's list down the elements first. Okay. So for C, in this case, my universal set, it is going to be none other than the natural numbers as mentioned, 0 to 13, 0, 1, 2, 3, and 13. Now, in this case, for A, can anybody tell me what is my odd number? What is my odd number over here? And just throw an answer for me. What is an odd number over here that I can use? What is? Just throw me a number. What is an odd number over here that I can possibly consider for A? What is an odd number? Alright, very good. Fiona is correct. Okay, it's one of them. Anybody else wants to give it a number? Just throw any random number. Based on this set over here, take note, because that is these are the numbers they are given. What is the number that's present here? Alright, that is good. Alright, that is good. Okay, let's see. 13579. That's good for you. Okay, very good questions. Depends on. Okay, I'll get back to that question later when I go to you when I launch the bubble launcher. Alright, Denise. Okay. Now then prime numbers, take note my prime numbers are 2, 3, 5, 7. Basically the numbers they are divisible by itself and 1. Alright, I fill in for this, so I hope you guys do know what these are the numbers that are involved. And now let's launch the bubble, list the elements in set C. Alright, 3, 2, 1, let's go. Alright, so for Denise to answer your question, in fact, natural numbers, depending on some internet sources, they say natural numbers don't include zero, natural numbers include zero, but in textbooks, we include zero as a whole natural number. Alright, so we just take note from that. Zero is actually a natural number because uh, it's naturally involved when we count them. That's why it sounds natural. We have zero things. That's why it's natural to include that number. I hope this makes sense. Okay, so I'll clarify with that for you, and after that, we will get back to you in the next lesson, shall we? Is that okay, Denise? Or you can actually, we will get back to you in the GDS platform as well. Alright, so we will clarify with you as soon as we can. Alright, thank you, Denise. Alright, last 10 seconds, take note. What is C? What are my factors of What are my factors of 15? Alright, time's up. So some of you all, most of you actually got it down. That's good. Okay, but some of you actually gave me a mixture of 1 and 4. Alright, let me just see 1 and 4. Okay, one answer 3. Okay, that's good because we realize what happened. Set C. Now let's list down the factors of 15 first. 15 we know in this case is 1, 3, 5, and 15. That's a good sign. But we have to take in consideration when we rename the set, we have to see whether we can plug it out from the universal set, which in this case we realize 15 is not part of the set. It is a factor, but in this case we cannot consider because 15 is not considered here. Therefore, the only numbers that are involved in this case is 1, 3, and 5. And therefore, 2 is my answer. So just take note over there, that's how we tackle this question involved. Alright, so next up, what are we going to do? This is actually a mock paper question for your part C. So what happens now? The sets are actually labeled there nicely for you. So what we can do now? Let's focus on this. List down the elements of A intersect C. So when we look at A intersect C, what this means is I'm finding the elements that are in common. So let's visualize. This is set A. This is set C. The elements in common are actually just none other than 1, 3, 5, 1, 3, 5. So all we need to do, elements that involves in both sets. Just write them down. It's gonna be 1, 3, 5. And that's my first part. Now in this case, if we were to list down for the second part, find the number of elements in B prime. Now this is a bit of a handful because you have to find the number of elements and then the union, and then we have to find the number involved. So let's do it step by step. B prime. Now B prime over here means not in B. So can anybody tell me a particular element or just name a few elements that are not in B for me? Which we take into consideration that this is my B over here. Okay, that right? It's okay. So give me some elements that are not in B. Not in B. Okay, write it down for me. What are some elements that are not in B? Very good, Denise. 0 is not in B. That's right. Any other elements that are involved here? Anybody else wants to try? Okay, so I'll write down the answers that are given. 0 is not in B. Very good as well. Following up nicely. 1 and 4 is also not in B. And in fact, if we carry on this particular flow, thank you for contributing, Denise. We realize that 6 is also not in B. And basically, whatever elements you do not see, they are not supposed to be present over there. Alright, now I am then now looking at B union C. So what is B none other than, considering where is my B, this is my B prime, sorry, not B, B prime, and C. C is this one. So union means I consider all the possible numbers. So in B prime, in both, only in C, in B prime, in C, and then the rest all in B. And then all we have to do afterwards is to actually none other than counting them. So number of elements, and remember that's the notation we have. It's just to count them. It is none other than 10. So that's the notion of number of elements. Now, the last question is a little bit special, okay, because we want to find the value of x. But what is this x? X is an element that is involved over here. Sorry for that. Let me just shift it down. Let me able to see. Sorry for the notion. Okay. Let me just write this somewhere else. Okay. Okay. So now we have to find such an element. Now, let's dissect this question bit by bit. Find the value of x such that x is part of this set over here. But it is not easy. So let's take a look first, step by step. First things first, what should we find? We are very confused because there's quite some information here. So what we can do, x is in this particular set. So do we agree we tackle this particular set first? We can do it. Alright, so A intersect B prime. Now, can anybody tell me what is a particular element in this particular intersection? A intersect B prime. What is the particular element that is important? I'll give you some time to write the answers. What is the particular element that's important? Okay, A intersect B prime. Very good, Denise. Once again, thank you for contributing. Realize it's one. What about the rest? Let me bring out to the floor. There's actually just one more element that is important. One more element. Okay, there's just actually one more element that is in A and B prime. Take a close look. This is my A. This is my B prime. Okay, besides one, what is in common in A and B prime? Okay, you can take a close look. Alright, very good. One of them answered. Very good. Right. Now we take a close look. We have actually conquered it. We know X is this, but X is not in C. Now, which element is not in C? 9, right? You realize 9 is not in C. If we take a close look now, we're going to see X is not in C. You realize 9 is not in C. So therefore, this case, X is equals to 9 because we want to find the particular element that's not in C. Right? This question, I hope you guys got it because it seems confusing, but that's how we solve it. Alright, all good? Okay, perfect. Okay, let's move on in this case to the next concept. Probability, and before that, this is an interesting question. Okay, okay. Let me just decipher it. Give me a moment. Yes, you can just write C prime. You can just write, let me see. Okay, C prime. It makes sense. Okay. What you mean is you want to just write. Oh, okay. I think I get what you mean. So you mean that we can just write in this manner. Is that correct? Okay, just clarify with me. Okay, I hope I'm not blocking my handwriting. No worries. Maybe after the lesson, maybe while you're typing, let me go through the next concept. I think I get what you mean. Okay. 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 Let me just absorb this. I'm sorry for everyone. Just give me a little while. Yes, that's right. C complement. All right. We say that this is not an element of C. So if it's C complement, we say that that particular element is not an element of C. Yeah, that is actually correct. Yeah, that's right. Yeah, no problem. All right. Sorry for that. Okay, next up. Now, moving on to the next recap over here. In a probability event, And in this case, let's take note. If I have total n outcomes and I only want k of them, how do we find out? In this case, we need to know what is all of them, which in this case over n. Total of them, I only want k of them, so it's going to be k over n. So that's how we fill in for the probability of single events. Alright, then following up nicely, what happens? We have a few different events that we need to consider. Okay, so the first one, I hope, is what we have also known as mutually exclusive events, whereby the keyword over here is no overlaps. Alright, no overlaps. Okay, that means there are no overlaps, everything is in common. If we say this, that means they are mutually exclusive. Alright, you can think of examples on your own, but the main examples I have for you is firstly, maybe one common example is either you can win or lose in a match, a certain match. That's one possibility. Or in this case, another example can be drawing or even numbers or multiples of 3. Again, these are some examples so long as there are no overlaps over here. Alright guys, no overlaps from a deck. Right? From a deck of cards. So these are some examples. Mainly, if you can think of more, go ahead from there. Following up, we have this thing called independent events. So if the result A does not affect keyword over here, this is the notion of does not affect the probability of another event. Alright, we say that A and B are actually what we call independent events. Okay, so example, common examples they all like to say drawing cards with replacement. Okay, that's the notion over here, drawing cards with replacement. Or another way, you can say flipping coins, okay, or even rolling a die. So these are independent events where one event does not affect the outcome of the other event. And again, what happens is you can think of other situations as well from there. Right now, with regards to these events, there are certain rules we can apply. So here over here, the addition rule only applies if they are mutually exclusive. We can say that this is none other than PA plus B. That's the addition rule. And in this case, for independent, if the two events are independent, we can say that they are multiplying. So PA times PB, we multiply them together. So independent multiply, mutually exclusive, we can add. So that's the notion over here. Now, next up, again, counting down to see whether you guys got my hint over here. Now, look at this particular question in the form of a question 2 of the mock paper. Let's see. Okay, what event is this? Okay, keyword. What event is this? Alright, non-trivial bubble is 3, 2, and 1. Let's go. Alright, because sometimes there are 4 choices, choose one. What event is this? If you get the words properly, yes, I think some people get it. The keyword over here is without replacement. So what event is this? Okay, I see the picture over here. Counting down, last 4, 3, 2, 1. Okay, let me clear the doubt over here. I think some of you are actually confused. So, why is this answer? Well, I'll tell the answer first. Why is this answer, in this case, answer number 4? Why is this dependent? Because suppose, let's think about this. The first one, I picked a black button. I'm not replacing it. It's the probability of my chance of getting a white button more. Okay? At first, there are 7. I picked one, there's only 6 and 2. The probability of picking a white button is going to increase. So because of me picking the black button, there are lesser buttons overall, and henceforth, if I were to pick a white button next, the probability is going to go up, up, up. So therefore, that's why Without replacement, we say it's dependent. Alright, I hope you guys are getting the notion of as such to why this is dependent. Okay? Because since you know it's dependent, that's where we have the particular concept of as such. Draw a tree diagram. So how will the tree diagram work? So first, there are two buttons. We draw one after the other, the replacement. So when we draw a tree diagram, we have as such the first draw. It's going to be either black or white. Now in this case, black and white. Let me bring it down to the floor. I think I've been talking a lot. Let me take a short break. Okay, let me bring it down to the floor. What is the number I should write here? And if you're and let me know what's the number. Alright, what's the number I should write over? Let me draw the box here on the blue color box. So what's the number I should write over here? I'll give you all some time to think about it. What's the number I'm going to write there? So read the question carefully. I draw a black color one. What's the probability of me drawing a black color in my first draw? I'll give you some time to think about it. What's the probability of me drawing my first draw? Alright, very good. So you realize some of you all have said 7/9. That's perfect because we have 9 buttons total and 7 buttons there. Okay, and henceforth, white I only have 9. Okay, that's how I do it. Now, if I were to move on in this case to my second draw, okay, because I picked a black color button, the result of drawing for my second draw is going to be as such. So if I were to draw a black color one next, and the white color one thereafter, okay, black color one, I draw a button. How many buttons do I have left? 8, right? And how many black buttons do I have left? 7. Pick one. I'm gonna have. Very good, Denise. But the top is correct, the bottom is not correct. Okay, because I only pick one button, so it's 6/8, which is 7/4. But go try Denise. There's the answer over there. Now, in this case about white button, I have not picked any white buttons yet. So it's gonna be 2 over number of buttons increased by 1. So 9 minus 1 is 8. So 2/8, that's going to be 1/4. Alright, so that's my white buttons over here. Alright, now let me bring it down to the floor for the second buttons over here. Now, since I pick a white button, can anybody tell me what is the probability of picking a white button? What would be the probability of picking a white button over here? Now, in this case, in the red color box, what's the probability over here? Oh, I tidy up my tree diagram a little. I tidy up my tree diagram a little bit. Alright, very good, Denise. Anybody else wants to give it another try? Okay, so I hope you have realized already this is none other than saying the white button is 1/8. Okay, thereafter you realize for the black button I still have 7 left, so it's 7. Okay, so this is the tree diagram that I have. Now guys, before I go on to the next slide, I want you all to take the screenshot because the next part is a bit rather long. Right, so I need you all to take a screenshot, and in this case, before I move on to the next one, I will give you a few seconds to do so. Let's take a quick screenshot. Alright, it up. Alright, okay, got it? Now, let's move on to the next part. So, after they ask you to draw a tree diagram, the possible ways for them to ask you to calculate the probability is always on the tree diagram. First up, if you refer to the tree diagram, calculate the probability that one button is white and the other is black. Okay, so how we do it, or I can say they are actually different colors. So there are two ways. The first button I pick as black, second button I pick as white, or the first button I pick as white, second button I pick as black. So if I have this orientation, what I need to do, I together, which is 7 over 9 times, follow your tree diagram from there, 1 over 4 plus 2 over 9 times 7 over 8. This is going to be equals to 7 over 18. That's the notion here. And next up, there are two ways to actually doing part 2. Both buttons are of the same color. You can actually do 1 minus part 1, or I'm actually going to think about, since you have the tree diagram, utilize it. Both have the same color, which in this case is going to be both black and white. Alright, this is none other than, you realize, 7 over 9 times 3 over 4 plus 2 over 9 times 1 over 8. This is going to give me 11 over 8. So you realize, or you can do 1 minus probability of B part 1. That is also possible. That is also possible. Two ways, but just in case you forget you can do the complement, you can do it via the tree diagram. Right, last one, a little bit special. Second button is black. Now, how do I then do this? Following the tree diagram, you want to look at the second draw is black. So what do we do? So we take note, first one can be white, second one must be black, or both are black. So that's motion over here. So therefore, multiplying the numbers together from the tree diagram that you guys screenshotted just now, we are going to have 7 over 9. Sorry, not 7 over 9. It's going to be 2 over 9. My mistake over here. So it's going to be 2 over 9 times 7 over 8. Or in this case, plus 7 over 9 times 6 over 9, which is 6 over 8, which is 3 over 4. Taking your calculator, punching, you're going to get 7 over 9. Right, so you realize this is very important in terms of my tree diagram because that is where I actually get my resources from. Okay, that is where I actually get my probabilities and stuff that we need to go through. Okay, now next up, moving on to a next mock paper question, the form of a bubble question build up again. So this is an example of a mock paper question, and all these key pointers here are going to help. Sounds a mouthful, but take note of what the bubble question is asking. Okay, 1 minute shouldn't take too long. Again, look at what the question is asking over here. Probability of drawing a pink marble at first. Alright, in terms of X and Y. Launching a bubble in 3, 2, 1. Let's go. Give it a shot. Yeah, alright. Okay, so you might want to restart your computer beyond because I think the rest is having the same thing. Moderator, can you assist beyond over here with the ID number 95792? Alright, 95792. Alright, for the rest, give it a try. Alright, with this particular number over here. Moderator, please assist beyond over here 95792, 95792. Alright, for the rest, alright, most of you are getting it. That's good. Alright. Counting down, last 10 seconds over here. Give it a best shot. Last 5, 4, 3, 2, 1. Alright, time is up. Again, probability. This is your simple probability. How many outcomes are there? In this case, there are going to be, let me try. It's going to be 8 plus x plus y. That's going to be the denominator. And then we have 8 pink bubbles. So that's where I have the answer to be 4. Alright, okay, I hope you guys get it from here. This one shouldn't be much of an issue, okay, because 8 big bubbles. You know. Alright, now following up nicely. Alright, following up nicely from there. Okay, we have one more. Give you one more hint over here. As such. Now, find the new total amount of bubbles. Now, before that, what happens is my total, let's recap, is going to be 8 plus x plus y. Given all these new arrangements over here, what is my new total bubbles? 6 remove 2. What is the new total? Additional take long and 6 remove 2. What is my new total? Counting down to my last 5. 4, 3, sorry, 2, 1. Okay, I think most of you got it. Again, let's look at the question. New total after the arrangement. So let's take a look. So it's going to be new total. Okay, my old total as such is from the above 8 plus x plus y. I am going to add 6. I'm going to remove 2. So my new total is x plus y plus 12. Right, so therefore my option answer is answer number 3. Okay, so that's what I have over here. Right, now let's bring it on to the actual question over here. Okay, a bit of a mouthful, so let's see. I am so the same question again, but overall what we need is this. We want to find the value of x and or y. So you realize over here that's where all my equation comes in. And what we have solved so far, from bubble question 4, we know that the probability of getting a pink marble is 1 over 3. And the equation that we can form from bubble question 4 is going to be 8 over x plus y plus 8. This is going to be 1 over 3. And as well as now, since the probability of a blue marble becomes 1 over 7, it, can anybody tell me, this one will take a while, but finally you are trying to think about this. Anybody tell me, what is then the probability in terms of x and y of drawing a blue marble? If probability of blue marble is this, okay, I'll give you some hints over here. We know the new total. We know the new total is going to be equals to x plus y plus 12. And we know this additional case as well. What is the probability of drawing a blue marble for this case? Alright, I'll give you some time. I know it's a little bit hard to write it down, but I'll give you some time. What is the probability of drawing a blue marble over here? I'll give you some time to write it down and think about it. What's the probability of drawing a blue marble? I give you some time. Okay, very good. Alright, that's actually correct, Denise. Alright, anybody else wants to give it a shot? Okay, so Denise has actually identified very good. Anybody else wants to give it a try? In fact, if we look at this, some hints over here for those who wants to try, I have y minus 2 blue marbles. I have y minus 2 blue marbles because initially I have y blue marbles over here. Y blue marbles. Right, so from here, I believe you all can see already that we have y minus 2 over x plus y plus 12, and this is equals to 1 over 7. And then you realize, oh, I have equation 1, I have equation 2, let's do simultaneous. But let's simplify equation 1 a little bit more. So I have 8 over x plus y plus 8 whole equals to 1 over 3. Simplify further, we'll have 24 equals to x plus y plus 8. This is equals to x plus y equals to 16. This I then call it my equation number 1. Then from here I have equation number 2, and I hope you guys know where this is coming next, because I'm going to cross multiply to get from here 7y minus 14 equals to x plus y plus 12. Let me bring this up a bit so that this is not working. Okay, and this is going to be continuing on, modifying further. I'm going to have x minus y equals to minus 26. So how I got this? 7y goes to the right. Okay, sorry for that. I got this. 7y goes to the right. Uh, 12 goes to the left. Rearranging, I'm getting this solution. So from here, you realize simultaneous, you can use the methods 1 or 2. But over here, we can actually realize, oh, if I do 1 minus 2, in this case, elimination, I'm going to get y minus 6y, that gives me 7y equals to 42, y is equals to 6. And from there, you can sub into any expressions you prefer. Sub y is equals to 6 into 1 or 2. Into 1, in this case as well, x plus 6. I'll sub in 1 for you all. X plus 6 equals to 16. X is equals to 10. So that's how you do it. Okay, so for simultaneous, depending on the situation, to solve it more efficiently, because my coefficients here are easy to eliminate, x, therefore I subtract them. Alright, in this case, let me make myself disappear. X equals to 10, y equals to 6. Alright, okay, let's quickly move on towards another part. So that's the first few parts with regards to probability and statistics. So probability and stats, I hope you guys got it. Now let's move on to the huge part over here, which is my statistical data analysis. So mean, there are two types without frequency, so that means you are not given the frequency, which is just summing all of them divided by n. We have some examples later. Or with the frequency, you are going to sum all of them with the frequency with each value and I divide by the total data values, which is itself. Alright? Following up and of course summing all the relevant frequencies. Okay, now median over here, you realize median. I'm looking at the value of the data in the what position over here? Okay, what position? What position am I looking at? Write down the particular particular phase I'm looking at. What position am I particularly looking at? Okay, recall what particular position I am looking at over here. Okay, so if you were to take a look over here, you realize for this particular part, I will just skip through it, but I think most of you guys got it. Very good. I see some responses. Median, I'm looking at the value of the data in the middle position. And in this case, I reach it in the descending order. And henceforth, for the mode, it will be the highest frequency. This is actually gone through inside too, so I just recap from there. Now, following up from there, what happens in this case, standard deviation without frequency or with frequency, the formula is a little bit tedious, but that's where I go through. If you the recap, is going to be summing of the squares over n minus the mean square. Or with frequency, that's going to be summing all the frequencies with the square, again, sum of the squares, just that with the frequency, replacing it with some terms, minus the mean square. Alright, so that's my standard deviation over here. Now, following up even further, we have the measures of square. Median, how do we do it in the percentile? So median value is actually the 50th percentile, lower quartile is actually the 25th percentile, upper is the 75th percentile, interquartile range is going to be at the upper quartile minus the lower quartile. Range, we take the extreme values. So it's going to be actually the highest value minus the lowest value. Okay, so these are the different statistics we can look at. Following up, with regards to my frequency curve over here, what we can see is, oh, okay, if I look at the curves, we can take a look at some shortcuts. If I look at the highest part, this is actually my total frequency. And if I cut it to 4 sections, the lower section over here is the 25th percentile, which actually corresponds to my lower quartile over here. Okay, if I bring it up to halfway there, I'm looking at the 50th percentile, which I'm then looking at the median over here. And next up, if I were to look at the upper quartile, it's going to be at the 75th percentile, which then I'm going to look at the upper quartile. And lastly, with the total frequency, I forgot to fill them up. That is actually just going to be the highest value correspondingly. Right, so these are the few things that we can look at in a cumulative frequency curve. That is where we can look at. And not only cumulative frequency curve, there's also the another diagram which we can look at in the box and Vickers plot, where our extreme ends will be none other than our lowest value and the highest value respectively. And the one that comes in the middle is what we call the median. The one on the left is the lower quartile, and the one on the further right is what we call the upper quartile. And so that's our box and whiskers plot. And further things to revise, let's see what we still have. Okay, so that's roughly about what we have the materials for box and for our statistical data analysis. But now, suppose a question with regards to this. So suppose this is the scores and the median mark is this. So how do we arrange them? It is a little bit tricky. I'll launch the bubble launcher in 3, 2, 1. Let's go. Okay, so what is the method? What is the proper way of arranging them in my ascending order? Keyword over here, it is a very important key. Median mark of the students is 36. How do I do it? Okay, let me take a look. Can everybody hear me from here? All right, can anyone, all of y'all hear me from here? Okay, if y'all cannot hear me, just give it a sound. Otherwise, just write it down. Okay, because I think I have some issues with the moderate from the sound. But I hope you guys can hear me loud and clear. Okay, counting down to my last 10, last 5. All right, let's take a look. Okay, some of you have actually given me your responses. That's a good note over here. Let me just see the results. Okay, most of you have responded. Let me see. Okay, most of you have responded. That's a good one. But let's see how we do the arrangement. Now, if you were to arrange the first one, we realize the median is actually not 36, but the median is the one that actually cuts over here, as suggested, the median. So therefore, it's going to be median. You realize this is me 32.5. Okay, that is not. Let's look at the next one. Okay, that's right. Median, if you calculate for each of one, it's going to be 33 plus 41 divided by 2. That's going to give me 37. That's not the median as well. If we move on, third one, we realize my median, we cannot calculate, but we realize if we take the average, it's going to be lesser than 33 if you were to follow the trend, because we can take the halfway point. It's going to be lesser than the other one, which is the maximum. So median is less than 33, so it's not possible. Henceforth, the answer is 4. Right, so that's how we gauge them as accordingly. Okay, for that part. Now, if we were to move on, in this case, for my actual example over here, how do we find the respective values? From here, let's take a look. Value of x. Now, we know from our question 6, we know this is our arrangement, which in this case is 26, 32, 33, x, 41, and 42. That is what we have. And we know our median is 36. Now, if we know our median is 36, that's the halfway point over here. Calculating it, we have then this arrangement 33 plus x over 2, which is equals to 36. Rearranging them, we have 33 plus x equals to 72. X is then 39. Okay, once we have this value, you realize for B and C, the rest of it you can use your calculator. With the calculator method I went through with you in the previous lesson, which is none other than, in this manner, x equals to 213 over 6 equals to 35.5. And the other one, because that's the total values, or the standard deviation, just take note the key values you need to add. Sum of the squares, you just sum them all, 7755, over 6 minus the mean square. Therefore, your answer is 56789, rounding up to 3SF. That's going to give me an answer of 568. Alright, the rest of these answers you can actually get to them through the calculator to review back to the previous genie class over here, which we have. Or remember the key values for standard deviation. I'll just make myself disappear for a while. There you'll see. Key values over here, this is the sum of squares. This is the total values, and this is my mean. Alright, so these are the three values that need to take note. Okay, three values need to take note. I hope you got these three values down before we move on. Alright, let's go. So now next, moving up to the marble question number 7. Again, what do the comparison means? Let's take a look. Okay, so if I compare within the mean scores, what do they correspond? Launching the bubble launcher in 3, 2, 1, let's go. Okay, so look at the definitions closely and try to see what they actually mean. This is going to be a little hard over here to sort of represent. Alright, then it's actually good. See good responses over here. For the rest, give it a shot. Right, counting down. Counting down to my last 20 seconds. For those of you to try, give it a shot. Alright, counting down to my last 10 seconds. 3, 2, 1. Alright, some of you all get it. That's good. I realize half of you all get it. But let's see why is it not 2, 3, and 4. 3, you realize is very corresponding to the mean, but the difference between the options is that this is just calculating the statistic. So I'm not comparing them. If I were to say it is number 1, I'm actually just calculating them accordingly. So I'm actually just none other than doing the calculation for me for number 3. I'm just calculating me. Most common score, this is none, this is just a mode. So looking at these two, I believe you know why we are looking at one, because we are seeing mean scores actually does which school perform better. Okay, now what does number 2 tell us then? Look at this question. Launching a bubble in 3, 2, 1. Let's go. Okay, I'll give you quite some hints already. What does this actually represent? The options are almost the same. So what does this represent over here? Standard deviation. Alright, counting down a little bit more. Counting down. Alright, give me some thought process. Remember what are the key things I said for 3 and 4 and the options to why one is the correct answer, and comparing the options now, what do we have? Okay, counting down to my last 5, 4, 3, 2, 1. Alright, I think most of you get it as well. So you realize if you look at the options carefully, this is actually answer for BQ7. Again, 3 and 4. One is counting the mean, calculating the mean of each. One is the mode. So standard deviation, we're looking at the consistency. Because if you recall from the previous lesson that you had with me for standard deviation, it's the values, how far is it relative to the mean. So the nearer it is to the mean, the more consistent it is. Alright, that is the notion over here. Alright, right now, let's follow up. Now, how would then this help? If you recall, how would we compare and comment on the mean scores? So let me just write down the values over here. X in this case is 39, mean in this case is 35.5, and my standard deviation in this case is 5.68. Now, if we were to compare and comment, recall the two bubble questions that we went through up and down. Okay, comparing the mean that we have over here, we are actually looking at and the standard deviation as well, looking at comparing them. In this case, how we would write down, okay, time is a little bit constrained here, so I'll just provide an explanation. If I were to look at such, if I were to compare the performance, because the mean scores are the same, mean scores are the same. Since the mean scores are the same, and both, that means they are equal to 75.5 over here, the performance are equally well. So both classes generally perform well equally. Okay? Generally perform equally well. That's the keyword over here. However, which one is more consistent? The lower standard deviation, because we got lower standard deviation. So we say class A performs perform more consistently sorry for that, as it has a lower standard deviation. So two key things we need to take note: mean and standard deviation. Lower standard deviation. Alright, so take note. One is to use the mean scores. One is to, let me color code. Sorry, one is to use the standard deviation. The other one is to use the compare each performance over there. Alright, now just one more exam question that I want to go through, and it will be done almost there. Alright, so one more question that if you were to look at how we attempt. Okay, one way is look at the cumulative frequency curve. So a few questions where we can ask very relevant towards the examples that we have. First one is going to be the ERP gantry. So use the graph to find the number of cars with more than 70. So how we do that? We trace 70. So 70 is around here. So 70. So we look at here, 70 is around here. So we trace from 70 if you look at the graph. And then over here. So if you count the axis very carefully, alright, each one is in tens, so 110, 120, so it's going to be 125. And the other one is going to be 76, so not more than 76. So what we do over here, we trace from 76, which you will see from my graph is going to be here. 76, and then we trace it here. I hope you all can see the graph clearly, guys. This is going to be 240. So therefore 240. So if I look at this range over here, I am looking at more than 70, not more than 76. I'm looking at this particular part over here. Because more than 70, less than 76, this is the part I'm looking at. Therefore, what we have over here is none other than 240 minus 125. Do a subtraction, it's going to be 150. Next up, more than 80, you guys know the trend, just that now we are looking at percentage. 80 trace up. 80 trace up, that's where we have 270 over here. So if we trace up, this is none other than looking at this part over here right now. So this part over here. Okay, so where we look at that part, but take note, I'm looking at percentage. So I need to perform an additional step. So that's where I need to do additional step, which is 300 minus 270 over how many cars are there? In this case, 300 cars. So therefore, I multiply by 100%. It's going to give me 10% over here. That is the notion. Right, so all these particular probabilities. Alright, lastly, what we can have? We can have the box and whiskers diagram. So what we have applied, what we're going to do here. So box and whiskers, remember the key trend over here. Firstly, draw out the axis. So I want to have a few numbers. So in this case, my number shouldn't exceed 90 because that is the representation of the car speeds over here, my x values. Then what happens? Okay, I need to calculate a few things. Lowest value, highest value, 25%. Lowest value, highest values, and my quartiles. Lower quartile, upper quartile, and median. 5 values. Remember. Okay, so my lowest value, realize is 60. Highest value is 90. So we're going to represent that with a dash. And other words, what I need to do, there are actually 300 cars. So easiest to start, median. 150, half of it. You've got to trace down. This is going to give me a value of 70.5. So that's going to give me a value of 70.5. Okay, not accurate. Let me just draw. Because it's the halfway mark. 7 70.5. On the actual exam, the graph will actually be bigger, so don't worry about it. So it's graph. Okay, next up, you realize if I were to look at the 25th percentile, so half of 150, that's going to be 75. So somewhere here. 75, I'm going to trace here. I'm going to trace now, that's going to be 68.5. Following the axis again, that's where I'm going to go to this part. So 68.5. So somewhere, let me just spin a bit, sorry for that. 68.5. So yes, over here. These are my values. 68.5 and 70.5. Alright, lastly what we have is our halfway mark. So we add 75 at the top, so 225 upper quartile. So that's going to be this way and down. So if we take a look, this is where we reach the notion of 74.5. Sorry for that, I need to be more accurate in my drawing. So over here. Alright, so remember on your graph paper, please be accurate with your drawing, 74.5. And over here, what we do is 74.5, trace it up. This is my upper quartile and finish the box. Okay, so remember your key values. This is my lowest value. This is my highest value. This is my lower quartile. This is my upper quartile. And this is my median. Right, box and whiskers, remember these 5 things. Lowest value, highest value, lower quartile, median, upper quartile. Alright, and that is actually it for today. So what remember, tip of the day, forget what you have done in the mistakes in the mock paper attempt, and remember what we have gone through for this lesson. Okay, so this is what we have went through, revision for sets, probability of combined diagrams, and statistical data analysis. Alright, that's it for me today. I hope that this has been a good review for you. Sorry for not really having the interaction over here, but I do hope it has been helpful. Bye, Denise. My dua has been helpful, and if there's any questions, let me know. If not, take care. See you then. I'll see you for subsequent lessons. Take care. Bye bye.